Looking at this, we are going to be working with rational exponents and looking at radicals and how to switch back and forth between those radicals and those fractional exponents, okay? So some of this is going to be review. So remember, whenever we're simplifying radicals, we do want to look at being able to do the factor tree. And remember, when we're doing the factor tree, we're trying to get those numbers down to nothing but prime numbers. So we want to get it down to prime numbers. When we're looking at prime numbers and we're trying to simplify using that factor tree, remember anything that you have pairs of are going to go on the outside. And then if it does not have a partner, that's what goes back on the inside. So no partner, it's going to go back on the inside. So we're going to look at some numbers and we're going to look at being able to simplify not just square roots, but cube roots, fourth roots, and so on. And we are going to use that concept of the factor tree. So looking at the first one, I have the cubed root of -8. So if I do the factor tree with that, remember, I can start with two numbers that multiply. So right here, I am going to ignore the 8, the negative. So I'm just breaking down the 8. So 2 is prime, 4 breaks down into 2 and 2. Those are both prime, so I'm good there. So now remember, this is a cubed root. So this number right here is the root. And that tells you, it's kind of like it's giving you directions. It's telling you how many you have to have in order to take that number outside of that radical. So for a cubed root, I have to have a group of 3. And I have that. So I have that group of 3. So that's going to give me the 2 on the outside. Now realize to get a -8, I would make that a -2. So the cubed root of -8 would be a -2. Everything was in that group of 3, so I don't have a radical anymore. That radical is gone. Okay, same thing right here. If I break down 27, I can break it down into 9 and 3, and then 3 and 3. So it's still a cubed root. So I have that set of 3 that I can take out, and again, it's a negative, so that would just be a -3. Okay? Now, looking at this one, right here, if I have a fourth root of the -1, remember, normally if it's an even one right here, that root is an even one, I can't get a negative from that. So looking at that, it wouldn't be possible to get that -1 from a fourth root, because remember, if I try to take a -1 and multiply it times itself 4 times, that's going to end up giving me a positive. So that wouldn't work right there. Okay, so this one, that's not going to be possible. All right, and then here we can simplify this one. Now remember, if I'm squaring something and square rooting, those are opposites of each other, so those would actually cancel out and just leave me with a -2. So that would be the -2 right there, because again, the squared is going to cancel out. So that's some stuff that we've already looked at. Now, what we're going to introduce today is some of those variables. So we're going to look at variables the same way, okay? You're still going to be able to do the factor tree if you want. So right here, if I'm doing the square root of 16, I do know the square root of 16 is going to be 4. So that's a perfect square root. For the square root of a to the 8th, so two different ways you can think about this. If you need to do a factor tree, if I have a to the 8th, that means I have 8 A's written out. So a to the 8th would mean I have 8 A's. So I'm still looking for pairs. So I have 1, 2, 3, 4 pairs. So those 4 pairs would all go on the outside, and that 4 would be my exponent. So this would be my answer. So that ends up being a perfect square root. Okay, if you don't want to do the factor tree kind of for the variables, then the shortcut way, my root technically here is a 2. For a square root, they don't write it. They're kind of expecting you to know that root is a 2. So all you have to do is take your exponent and divide it by the root. If I do that, I get 4, so that tells me there are 4 pairs for those A's. So either way you want to think of your variables, either I can write it out kind of like the factor tree, or I can just take that exponent and divide it by the root. So here, I'm going to break down the 12. So that would be 4 times 3, and then I got a 2 and a 2. Okay, so for this square root, I have a pair of 2's that I can take out. This one doesn't have a partner, so that's going to go back under that radical. Okay, same thing for your variables. If it doesn't have a partner, it goes back under the radical. If it does have a partner, it goes on the outside. So because this is a square root, if I have n to the 5th, so I can think about it and say, okay, how many times can 2 go into 5? It can go in twice, so that would be n squared. And if I go 2 times 2 is 4, that leaves me with 1 left over. That 1 left over goes back under that radical. Okay, same thing for the 9. How many times will 2 go into 9? 2 will go into 9 4 times, and that gives me an 8, so that means I have 1 left over. So again, if you don't like the dividing by 2, I can write these out and look at how many pairs I have. So that is just simplifying that radical part. So now realize on this one, I did have something on the outside to start with. So the only extra step is I have to take what I started with right there and multiply it by what I took out. Okay, so I'm going to do 3 times 2. That gives me the 6. Now remember, with variables, I'm adding those exponents. So n squared and n, that means I have a total of 3 of them now. And then m to the 4th and m would be a total of 5. And then the underneath the radical didn't change. So this would be my complete answer here. And so if you have something on the outside, you don't do anything with it until the very end. Once whatever you've taken out, that's what you're going to multiply. All right, so again, the next one I have a cubed root. So remember, that root is what I'm going to divide those exponents by. So right here, 6 divided by 3 gives me 2. 9 divided by 3 gives me 3, and that would be my answer. So that's a perfect cubed root. I didn't have a number in the front, so you didn't have to worry about doing the factor tree. All right, and last example here, I have a 4th root. So again, I'm going to do the factor tree here. So I'm going to start with 2 and 16. 16 breaks down into 8 and 2, 4 and 2, and then 2 and 2. So I got it down to all my primes. Now remember, this is a 4th root, so that tells me I need a group of 4 in order to take a number out. So right here, I have a group of 4, so I can take that 2 out once. This 2 was not part of a group, so that is going to go back under that radical. Okay, now let's look at the variables. So again, because I have a 4th root, that's what I'm dividing by. So I'm going to do 8 divided by 4. That gives me 2. And then 12 divided by 4 gives me 3. So all of the variables were perfect 4th roots. I just had this 2 left over that was not part of that group of 4. So that is simplifying just that radical part. So now don't forget, I have this negative 2 in the front, so I need to take this negative 2 and multiply it by what I took out. So negative 2 times 2 is negative 4, and then all those variables are staying the same, and then I have that 4th root of 2. So that would be my answer. Okay, so again, when we're simplifying radicals, we're going to do the factor tree with the whole numbers in the front there. And then for your variables, all you have to do is divide by your root, or you can write it out if it helps you that way to see how many pairs, groups of 3, groups of 4, whatever you're looking for. Okay? All right, next concept, we're going to write radicals as those rational exponents. So that's switching from a radical to a fraction and vice versa. So when we're looking at that and switching, your numerator on those fractions, that is going to be your exponent inside the radical. Okay, so whatever the numerator is, that's the exponent inside the radical. Your denominator is going to be the root. Remember, that's kind of like your index right here, so that would be a root of 2. 2, this has a root of 3, root of 4. So we're going to be able to rewrite these as radicals and vice versa. So looking at the first one, if I have 27 raised to the 1/3 power, if I want to rewrite it in radical form, this 3 means this is a cubed root of 27. The 1 would be the exponent on the 27. So that means the cubed root of 27. And if I ask you to simplify, what is the cubed root of 27? That would be 3, because I know if I multiply 3 times 3 times 3, I'm going to get that 27. Okay? Same thing here. This is my root, so this is a regular square root of 64. And I know the square root of 64 is 8. Okay? Same thing here, but this is going to be, the 3 right here is a cubed root of 64. That means what number times itself 3 times will give you 64, and that ends up giving you a 4. Okay, so these are the ones we've kind of already looked at throughout the year. Now we're going to look at some other fractions. So looking at this one, remember the denominator is your root. So this is a 4th root of 81, and then that's going to be a power of 3. So the numerator is the exponent on the inside. Now if I'm asking you to simplify this without a calculator, it's really hard to do 81 to the 3rd power. So we're going to kind of look at it like this. I'm going to do the 4th root of 81 first. So if I look at the fourth root of 81, what number times itself 4 times would give me 81? Well, over here, I knew 3 times 3 times 3 was 27. If I multiply that by another 3, I'm going to get that 81. So this part would give me 3, and then I'm going to raise that 3 to the third power. So here when I rewrite it, it's a lot easier for me to find the fourth root of 81 than it is to raise 81 to the third power. So that's what we're going to do first right here. And then now 3 to the third power, I know is 27. Okay, so let's look at another one. So if I have 16 to the 3 halves, remember this is the square root of 16. That numerator is an exponent on the outside. Oh, sorry, inside. So looking at this, if I look at this, what is the square root of 16? I know that's 4. And then if I look at 4 to the third, I know that gives me 64. So you are going to see some of these numbers being kind of repetitive, and you'll probably start to memorize some of these exponents. All right. So looking at this one again, the denominator, this means it's just a regular square root of 4 to the 5th power. So here, if I do the square root of 4, I know that is 2, and 2 to the 5th is going to give me that 32. Okay, next one's pretty easy because you do know, like when you're looking at this, that's going to be an 8th root, but I have a 1, and 1 to any power is going to give you 1, so that's just going to be 1. So that one's pretty easy to work with. Okay, so this is just making sure that I can take a fractional exponent and rewrite it in that radical form. Okay, so now I need to be able to do that on the opposite as well. So if I give you this, I should be able to write it as that rational exponent. So my base is the same, so that 12 doesn't change. Here, remember this is my denominator. I don't have an exponent in the inside, so that's just going to be 12 to the 1/3. Base is 8. I don't have an exponent, so that would just be a 1/5. That number on the outside, that root, is always your denominator. So right here, I would have negative 10 7/3. So that root is always going to go as the denominator. Same thing right here. This would be 15 to the 3/8. Okay, so looking at this, make sure I can write it both ways. If I can go from fraction to radical and radical to fraction. And then looking at this, if we're looking at simplifying with the different radicals, just make sure, looking at this, it looks like division, so make sure we're going to subtract our exponents. So we're actually going to change these radicals to fractional exponents. It's a lot easier to look at it that way when you're subtracting. So we are going to change them to the fractional exponents. So when I change this one, this would be h to the 3/4, and this one would be h to the 2/8. Okay, so now I'm looking at it. If I'm asking you to divide, I'm simplifying these. I'm just going to subtract these exponents. So that's going to be 3/4 minus the 2/8. Now remember, when you're subtracting or adding fractions, they do have to have the same denominator. So this one actually simplifies to a 1/4 when I reduce it. So if I do 3/4 minus 1/4, I get 2/4. So this would be h to the 1/2 power because this reduces. So always reduce your fractions. So that's all we're going to do. Change them to fractions and then just subtract your exponents. So if I look at this one, this would be m to the 3/4 divided by m to the 2/3. So again, I'm going to take my fractions, the 3/4 minus the 2/3. Now here, neither one of those reduces, so I need to get a common denominator, and 4 and 3 have 12 in common. So remember, from previous math classes, if I have a denominator of 12 here, I multiplied 4 times 3 to get that 12, so I'm going to multiply the top by 3. And then same thing here, I multiplied that by 4, so I'm going to multiply the top by 4. So for this one, I would get m to the 1/12 power. Okay, so hopefully you're getting the hang of that. Again, all you're going to do is change them to the fractions and then subtract them to get your answer. All right, last little part, we are going to be solving equations with these rational exponents. You're going to solve them like a normal equation. You do want to get the variable by itself. So just like with any other equation, if they're adding, you're going to subtract. They're multiplying, you're going to divide. We're going to get that variable by itself. with these fractional exponents, to get rid of those, all you're going to do is you are going to raise it to the reciprocal. So when I say raise it to the reciprocal power, if I have 4/5 and I ask you what's the reciprocal of 4/5, you're going to tell me 5/4. You just flip it. Okay, so I flip the numerator and the denominator, and when I look at that, every time you multiply a fraction by its reciprocal, those are going to cancel, those are going to cancel, and it's always going to give you 1. So that's why we multiply by the reciprocal. Okay, so looking at the first one, these are pretty simple. I have w to the 2/3 equals 4. I want to get that w by itself, so I'm going to raise this to the reciprocal power. So I'm going to raise it to the 3/2. Remember, what you do to one side, you have to do to the other. So this cancels and leaves me with w. And then here, this is what we just did on the front side. I need to be able to write this with that radical form so I can simplify it. So remember, the denominator means this is a square root of 4 to the 3rd. So if I look at this, the square root of 4 to the 3rd, the square root of 4 is 2, and then 2 to the 3rd power. So remember, this is really just 2 to the 3rd power. So 2 to the 3rd power gives me 8, and that would be my answer. All right, so looking at the next one, now I have a 3/2, so I'm going to raise it to the reciprocal, which would be 2/3. Those cancel, leave me with y. And then remember, I want to rewrite this. So that denominator tells me this is the cubed root of 27 to the 2nd power. So now looking at this, the cubed root of 27 means what times itself 3 times would give you 27. So that would be 3, and 3 squared is 9. So we're still using that same concept as we did on the front. Just make sure you're multiplying by that reciprocal power first, and then that sets up the radical for you to simplify. Okay, looking at some of these other ones, these were pretty simple. You just had a variable. You can have some with parentheses. So since this one has parentheses, that means everything inside that parentheses is being raised to the 3/2 power. That means I have to raise it to the 2/3 power first. So I have to get rid of those parentheses first. So that cancels and just leaves me with k minus 27. Right here, I'm going to rewrite this. So remember, this means the cubed root of 64 squared. So looking at this, the cubed root of 64 would be 4, and 4 squared is 16. So this is really the equation I'm looking at, so all I have to do is add 27 over to that side. So if I add 27 over to that side, you should get 43. Now, the difference between this one and looking over here at this one, I only have parentheses around this part, so that tells me I need to move that 1 over first. So the only thing that's being raised to the 3/4 exponent is the 27 and the p right here, so I have to move that 1 over first. So I'm going to add 1 over there. So now I can get rid of that fractional exponent. So now I'm going to raise this side to the 4/3 power, and the same on this side. So that's going to cancel and just leave me with the 27p. Over here, remember, this is the cubed root of 27 to the 4th power. So the cubed root of 27 is 3, and then I'm going to do 3 to the 4th power, and we actually did this on the other side, but if I'm doing 3 to the 4th power, that gives me 81. And then I'm just going to divide by 27, and you should get 3. So again, make sure you know the difference of when you're raising that reciprocal power, because here everything was being raised, so all of it was in parentheses, so I had to do that first. Here I had to move the 1 first. And now looking at this last one, I'm going to move the 20 and the 8 because the only thing that has that exponent is the b. So I'm going to subtract 20 first. And then I'm going to move the 8 over by dividing by 8. So now I've got that variable with that exponent by itself. So now looking at this, I can raise it to the reciprocal. And the reciprocal of 1/4 is just 4. So that's going to cancel. Over here, I'm just doing 2 to the 4th power, which gives you 16. Okay, so make sure with the equations you understand when you're raising it to that reciprocal. Here, everything was in parentheses, so I had to do it first. Here, I had to move the 1 first. Here, I had to move the 20 and the 8 because there were no parentheses, and the only thing that was being raised was that b value.